continue my series of videos about ClojureScript. I don't know exactly when in this timeline this video will be positioned because this is a little bit more advanced feature, but basically I want to explain how to do some kind of parsing and serializing in a stateful manner but with immutable things. So let's start with the basics. I am writing for a personal project a serializer and deserializer of a function that I am calling EBN. It's basically like loosely inspired on being code, but the idea is if I want to serialize a NIO, I will just serialize as an N. If I want to serialize a number like 20, I am going to put M between the number, and the same for like 20.2. If I want to serialize a keyword, I will basically get the size of the keyword. In this case, it's 7 chars, and I am going to put K7K to say this keyword will have 7 chars, and that basically will be the keyword. The same thing with string, but with S instead of like instead of being like string, and the symbol, the same thing with a Y. And the interesting part is the collection. Collection basically is a beginning and an end. So it starts with V and ends with E. Okay, so let's suppose that I want to serialize like 3 NIO elements. It's just V, that basically says that it's the start of the vector, 3 NIOs, and then the E as the terminator. Okay, now I want to deserialize this. I could do the same thing, basically some kind of like from EBN, and basically say that this should be like 3 NIOs inside a vector, and that would be fine for smaller collections. But the thing is, I want the serializer and this deserializer to work in a network environment. And in a network environment, I can receive things like first the V, then the 2 N's, and then the third N and the terminator. So I don't want to basically try to parse everything and then say, oh, it didn't work, so stop everything and then start again from the beginning when I receive more data, because this is basically loss of resources, and also because I already did this on the past and it's slow, really slow. So I decided to do a stateful decoder. So the first thing for a stateful decoder will be to deserialize the NIO, which is the most basic stuff. You just return the NIO. It's just a single char, and it will be basically what I expect. And if, for example, I want to return something else here, like I got more stuff, then I get this rest, which basically means the next thing that I need to parse. In this case, I just want to serialize a number, a NIO, so it will not serialize the rest. But if I am inside a vector, then I will have to deserialize the NIO and deserialize the number. Okay, so far so good. NIO works. Let's save the file. It basically says that all my assertions have passed. And now I want to deserialize a number. So let's get a value over time. So what I am going to do here, I am going to decide on a pattern. So the thing that I want to do is to be able to create a deserializer that if I receive something that's not complete yet, it will basically return me a function. And that function will be what we used to call in functional programming a thunk. That basically is the rest of the function. This approach sometimes is called the continuation, but the continuation pattern is a little bit different on what I am doing here, but I am not going to get into details on that. So okay, so how do I do this kind of check? So I want to check that a serializer that tries to deserialize an empty string is a function. So here I can check that it's a function, and if I want, what I actually want is also to return this in some way to my next step. So one thing that is easy to do this is due to. So I am going to feed something to deserialize, and with the result of this, I am going to check if it's a function. And that will give me a success test and also the result of the serializer as the return. So I can basically put this inside a let, like deserialize. And that's exactly what I am doing here. So let's try to deserialize the number 20. If you look at the IBAN, you see that it is this format, M20M. So let's start by trying to parse M2. And this will obviously fail because I have no matching clause for M. If I am going to look at the deserialize function, you will see that it's a case that if the first element of my string is an N, it will just return the number. And if it's a nil, meaning that the string is empty, so the first element doesn't exist, it will just be deserialized because the thunk is basically the function itself. Like I have nothing to parse, so I'm gonna start from the beginning. So let's start with the first clause, the M clause. What I want to do here is to have a number deserializer. But I also want not only to pass the string, but also pass how much I parsed so far. So if you are familiar with deserializers, with a stateful thing in object-oriented programming and other stuff, you will probably have some kind of state, let's say an atom, and that atom will keep track of what was already parsed and will be updating this thing. I don't want to do that. I want to do a pure functional approach. And that means that I am not going to pass anything that's mutable. I am going to pass that I am deserialize something, and what I deserialized so far is nothing. So I'm starting from scratch. Also, if you see here, subs, basically it's the string without the first char. So let's do this. Let's just do rest instead of like getting the M, because I don't care about the M. I already know that I am deserializing a string, or sorry, a number. So let's do the number deserialize first. So the number deserialized will get a string that needs to be converted to number, and how much it deserialized so far. So the first thing that I want to get is that string already complete? Meaning that I already have the full numbers that I want, and I have like the terminator. And to do that, I am going to do a regex. So to do that, I basically get numbers. It's an asterisk. Oh, it's the beginning of the string. It's an asterisk because basically this means it can be anything. It can be like the first element, or it can be just the terminator if I have already parsed other numbers previously, and I want the M. This will get me 1M, which is actually not what I want, because I don't want this M on my result. So I am just going to do this, and now I have 1M and basically 1. But here I have another problem. I don't know if I receive the M or not. So I am going to put the M in parentheses, and now I have 3 elements. How much the regex matched? the number that it matched, and if it matched also an M. And here I am going to put everything into a single regular expression, into a single let expression. Basically, like the full match, the number, and the terminator. And this will be obviously not 1M, it will be the string. Okay, so first thing, if I have the terminator, then everything is okay. I already parsed everything that I wanted, so I want to return a result that is basically, I am on ClojureScript here, so I'm going to do the parseInt. So the parseInt, it's not only this number, it's also what I parsed so far. So I have to concatenate things so far with the number. And here's the interesting part. Because this is a string, I can get things after the M. So the rest, it's basically a substring of the current string and the number of chars that full match contains. And that is the result of my element. So this will obviously not work because, well, I expected a function and I got nil as a result, because the terminator is not true for this first parsing. So what I want to do here is, if there's no terminator, then this means that the number, it's present, but I cannot terminate the parsing. I cannot basically save everything, cannot return anything for the user. So I am going to return an anonymous function, which is basically the number deserializer with like the string that I got, because I don't have the terminator, so I just get the full string and then the full string will be the argument so far, because it means that I already was fed some string, so the next number deserializer will have to get the string, and the number deserializer basically will receive another string that will be concatenated somehow in this thing that I already received. And that will get my test passing, and I want to be sure that 0 will also return a function. And finally, I want to be sure that if I get a terminator, then this will be 20. And I did not get 20. And why I did not get 20? It's simple, because I am passing only the string here. And I have to concatenate the string. This is not right. The string, what I parsed so far with the string. Otherwise, I am discarding this first two. That's why it's always good to be testing. Oh, I have to save also my file, otherwise I will not be able to get the test. And here I have my number deserializer in a pure functional way. Okay, so number serializer, it's actually quite simple, but we have like more complicated stuff going on. And the more complicated stuff, it's basically the vector deserializer. And why is that it's more complicated? It's because for each element I have to parse stuff. So let's do that. This video will be a little bit bigger than normal. Okay, so here is what I want in my vector deserializer. I want to deserialize, basically I'm starting with a V to define that I started with a vector, and I want to deserialize a nil, and I am going to actually put something else here. I'm going to put a number, let's say the number 20. So here's 2, and I am going to finish the 20 here. So now I have a nile that's fully parsed, but the vector didn't end. Now I have a number that started, it's the M2, but it didn't end. And now 20 finished, and I also added a nile, but it didn't end. And finally I deserialize everything. Because this can, oh, and the result will be nile, 20, and nile. And this 20, it's basically separated into deserializers. So let's start with the small steps, otherwise we can be overwhelmed with everything that I am doing here. Okay, so the first thing is it will probably crash, and it did, because I don't have the matching clause v. So let's do the matching clause v. And this will be a vector deserializer. And exactly the same as I did with the number deserializer, I will get the rest, because I want to discard the v, and the so far will be an empty vector. I don't have a vector deserializer, so let's just create this real quick. And I have a string that I want to parse. I have how much I parsed so far, and I am going to just return so far for now. Okay, obviously it didn't work, but that was expected. So before we work on this, let me just print what am I parsing. That's my string, and I am going to print how much did I parse, and that will be so far. And I am going to print an empty string here, otherwise it will be harder to get. So what I am parsing right now, it's an empty string. So how do I parse an empty string? I basically ask for deserialize to parse a string. And that will be my result. So it worked, my test passed. So now let's deserialize a nile. And as you can see, it didn't work. And why it didn't work? Because this function, deserialize a string, basically says, okay, I deserialized the string, and that got me a result. So I'm going to return the result for the user, but I did not terminate the vector. And I did not even use the so far in any way, which means that this is completely wrong. So the first thing that I want to do is to add a conditional, and first thing I want to see if the first element of this string is an ending vector, basically the terminator. And if it's the terminator, then I am going to return how much I parsed so far. Okay, and the rest will be something else. I am going to explain this a little bit. If it's not a terminator, then I call deserialize. Again, it didn't work because it wasn't the terminator. But I at least have something to work with. So I don't have the terminator here, and I need to somehow get this result inside my thunk. Basically create an anonymous function that will keep deserializing until the moment that the terminator appears. So let's just convert this to a let. Result from deserialize, and let's just deserialize, put everything inside here. So if I don't have a terminator, what I actually want is a vector deserializer. The string will be the next thing that will be fed to this deserializer, and so far will be the conjunction of what I have so far with the result of the result from the serialize. Okay, this will basically say that I am now parsing a nile, and how much did I parse? A nile. Okay, so far things seems to be working fine. So let's do the next step. This will say that how much am I parsing, what I am parsing, what I am parsing, and I got two different niles. And why is that? It's kind of weird. So let's just print the result from the serialize here, and it will be clear what happened. So the first result from the serialize here, well, actually I am going to move the print line here because it will be easier to get. Okay, so the first is a function, the second is a real result, and the third is a function because that is the thunk or the continuation from the number deserializer when the number was not complete. And that's exactly what happened. M2, it's a number, it's not complete, so this will be this result here, this inner anonymous function. Okay, so I have to use this somehow because first I cannot make a conj here because first I don't have the result, and second I cannot call deserialize here because if I just call deserialize, then this anonymous function that's basically something that was partially parsed previously, it will be lost. So let's explain that, basically showing on the code. Let's suppose that I just do the following. I want to check if the result from the serialize is a function, and if it is, I just call vector deserializer with a string, and I basically do nothing with it so far. This obviously will not work, and oh, this did work for now, but we will see soon why this won't. And it will be basically here. The deserialize here will get no matching clause 0 because this 0 here does not match any of these clauses. And sure, it won't, because it's not what we are doing right now. What we need to do is we need to call this thunk that was returned in the previous step and not the deserialize. Okay, so let's do that. This also means that this deserialize here needs to disappear. We cannot have, we cannot have this function here because it will not always be deserialized. So let's call previous result, and previous result will be this, and here we are gonna feed the seed for the previous result, and it was the serialize itself because that's the first call that we did. And now I have a different error. Its key must be integer. And why is that? Well, basically because I did not pass the previous result to any of these things. So for the vector deserializer, I want to pass something, and for the vector deserializer, I want to pass something. So the vector deserializer, what will be what I want to pass? And that's actually the easiest part, because I want the previous result from the serializer, the thunk, the number deserializer that I returned here, because it's not complete. Basically, the inner parser were not complete, so I want to keep parsing that inner parser. It's already starting to be too big, so let's just split this conditional into different lines because it will be easier to read. And usually I don't like to use else if I can get a better explanation, so in this case I want to get the real final parser result, because it's easier to read that it's not a partial parser, it's a final parser. And now I have to ask, okay, what do I do with the vector deserializer here? I have the string, I have the so far, but I am missing the inner argument. And I could do the deserialize. And it seems right in some way, but we will see soon that's not. So let's just keep iterating, and as you can see, I have a no matching clause E. And why I have a no matching clause here? Because basically I'm having deserialize as an argument, and deserialize is basically this function, and I want to somehow retrofit this function, and I cannot call this parser here. So to explain a little bit better, this condition here cannot call this function because it's a terminal. I can reorganize this code to be an if and basically just call previous result like on the branches that make sense, but I am going to just get a delay and basically ask to just dereference thing here. It's easier and gets the code more beautiful, but I cannot print this anymore, otherwise I will be dereferentiating the result from the serialize, and I will get the same crash again. So now this code should work, and the result is incorrect. And why is incorrect? It's missing a nil. It's missing this last nil. And it's easy to see why, because when I got vector deserializer here, I did not do anything about the other part of the result from the serialize. Result from the serialize, it's a two-element field. It's a result and it's a rest, basically the next things that I want to parse. So when I got a final parser result from the number, I got the number 20 and I got a rest of n. And it's easy to check this if I just call serialize.deserialize m2 0 mn, and you can see that I got the result m and the rest n. And I am not using this rest, this n, in any way. And that's the problem. That's basically my failure here. So what I actually need to do is that I need to call deserialize with the rest of the result from deserialize. So now I am basically saying, okay, I got a result, it's a valid result, it's a number, so I am going to add this result with my accumulator here that I called so far. But I also need to have some previous result here that's basically the rest of the string that I parsed right now. And that will get me something that's not correct. And why is that? Why is that indeed? Deserialize should be correct. So let's just put a do here so I can just print the result. And see what will happen. Oh, yes, of course. Okay, so here's the thing. I never call this function because the next step from this serializer, it's basically the E, that's the terminal, and the terminal will basically terminate the process. So this means that, yes, I need to somehow, this is not a thunk basically, this is a recur. I will have to recur with the rest of the function, call the serialize, but like as a function, and conjunction. This is not a thunk. This is a recursion, because basically on this case here I am adding two elements at once. So it's not like my parser cannot continue. It can, and it will. So I'm just gonna call recur and not a thunk. Otherwise, if like my data was complete, like I do something like serializer / deserialize, and simply, I don't know, it's complete already. It's a vector with an IO and an end. It will just return something that's not correct. It needs to be like a vector. It's a complete vector. So let's just do a recur. And for some reason it's not. Yes, I miss its result, not return. And now I finally have the right thing, and I have the right thing here. But this rest, it's incorrect. Because if I have something like this, the rest should be like an empty O, an M. So let's also assert for this. And as you can see now, I have a mismatch. And what exactly is the rest? So basically, if my string, the first element of my string that I am parsing right now, it's an E, then this means that I already have an E. So the rest is the substring of the string that I am parsing right now minus 1. So now this passes, and if I had something like serializer.deserialize with a vector with an IO, the end of the vector, and then some new vector, I get the rest correctly. So that's it for now. Okay, this is a stateful parser. Basically, it does have state, but at the same time it's immutable, meaning that each step is self-contained and it does not use immutability in any way. This opens the possibility for a lot of interesting stuff. So let's see one of this. Let's define a deserializer 1. and this is the start of a vector. And now let's start a deserializer 2, that's deserializer 1 with some kind of number. Let's say M2. So this is not yet complete, as you can see. So let's start the D3 with like D2 with the number 2. Let's put D4, the result of D3, with the end of the number. And finally, let's put D5 with D4. Oh, with the end of the vector. And now D5 contains the result. It's a vector with the number 22 inside of it. It closes the number, it closes the vector. Okay, let's do something interesting. Let's start the parser from this position, D3. So I want D3, but now I am going to add 5, 4, 5, M, and then the vector. And as you can see, I have 2, 2, 4, 5, and the end of the vector. Okay, let's start now from D4, and I am going to add an nio and end the vector. And now I have 22 and nio and the end of the vector. So this is interesting because my parser, it's actually stateless. Each one of these individual elements are actually things that I can parse individually, and I don't have to worry about like undo, redo, or something like this. So supposing, obviously is not the case because my string will be correct, but supposingly I wanted to have some kind of, I don't know, correction on some unreliable data. So I parse the thing, and at the end I get an invalid result, so I backtrack up to a point that things are valid and then reparse everything. It is possible with this parser. It's not possible if this was with mutability, because if I had mutability, I cannot backtrack things that already happened. And here, for all that D1 it's known, for all that's worth, D1 only knows that V was started. D3 only knows that there's a number that starts with 22 that's happening. So if it will end here, or if it will be concatenated with some other stuff and be another number, or if it will end this and here, but also get another nil, it doesn't matter. It's basically immutable. And it's not actually occupying more memory than it needs, because that's exactly what a mutability will do. So this is like structure sharing. Basically D3 it's sharing the structure of D2, and D4 is sharing the structure of D2 and D3. So I'm not occupying more memory for this to keep this undo state. It's basically intermediate steps, like one by one. So that's what I wanted to show, a different way of doing like stateful programming without actually mutating things. So I hope you liked this video, and see you on the next one.